My name's Ben Riga. I am a technical evangelist with Microsoft. I work in Corp. I focus exclusively on Windows Phone, and so I spend a lot of time thinking about Windows Phone. How many people here are already Windows Phone developers? Excellent. How many people here aren't? Better. Okay, it's great. We're going to convert those of you that didn't put your hands up. Just shy, I guess. Okay. So first things first, my email address is on the slide. Please feel free to take it down if you have to email me questions. Maybe you're shy here, or maybe you remember one tomorrow. Feel free to email me. I'm more than happy to help with any questions you might have. Anything that is going to help you build more apps for the platform, that's my job to make sure that you guys are successful. The other thing, I'm not going to make any threats, but please follow me on Twitter, or the puppy gets it. My Twitter tag is at Ben Riga, and of course on Twitter I primarily talk about Windows Phone stuff, so any Windows Phone related stuff. And of course, if you want to message me on Twitter, please do so. It's my pleasure to answer any questions. And of course, I'm constantly posting stuff that I see and stuff that I create, content and so on. So please follow me. And of course, you know, it's for the puppy, right? Okay, so today we're going to talk about fast application switching. And then we're going to talk about background tasks. They're sort of related, but not really. They're two things that are sort of important. Fast application switching is something that really every application should take advantage of. There's no reason you shouldn't. The increase in satisfaction that you get from users appreciating applications that do fast app switching is just a huge bonus for your apps. And so we're going to talk about what that is. We'll first talk about the execution model for Windows Phone and how apps go from state to state and what that all means. And then we'll go through and describe the things that you need to do. And there's certain gotchas that you have to watch out for. And so we'll try and walk you through some of that. I have some demos that hopefully will demonstrate the various things that you need to take care of when you do fast application switching, and also related to that, tombstoning, which is kind of very much related. And then we'll talk about background tasks. We'll talk about generic agents. We'll talk about the background transfer service. We'll talk about alarms and reminders. We'll talk briefly about background audio as well. That's something that's very important, but only if you're doing audio, and that's kind of a niche scenario. So I figured I had a limited amount of time, and that was probably one that not a lot of people are using. If you do, then please come see me later, and we can talk about that. Okay, so first things first. Oh, of course. So first things first is let me actually show you what fast application switching is. And the easiest way to do that is to show you what an end user sees when they do fast application switching. And so let me, of course, connect. There we go. So I am using a device. This is something that you unfortunately cannot do on your devices, but I have a special fancy magic gold device. And it allows me to actually project directly what's going on my screen on my device onto the screen so that you guys can see what I'm doing. And so here I am actually on my start screen. And of course, I have lots of apps, and I can start apps. So for instance, I could start, let me see, what am I going to start? I can start messaging, for instance. I don't have too many messages here. Now, what your end users will want to do very often is hit the start button. And that actually has put that messaging task in the background, and then they might want to come back to it. And what you'll see is that the application comes back very quickly. I can also, if I push and hold on the back button, this is a new feature that we added in Mango. This allows you to very quickly get from task to task. And so I can switch, for instance, you can see what I was doing on the break here. Let me just get a few more points here. You saw what happened there. I switched from my screen to, yeah, that's great. But you saw what happened there is I switched from my screen to a game, and that game is huge. It actually takes probably about 30 seconds to load because it's got lots of graphics and maps and textures and all that good stuff. But it switched immediately as soon as I switched back to it. And that's what when we talk about fast application switching, that's the experience we want almost every application to do. Now, of course, there's a limited amount of memory in the device, and so not every application can do it. There's up to you hit your memory and then you start getting tombstoned. And when you start getting tombstoned, then you get the experience, and I'll show this later, getting the resume screen, where you get the resuming and then the dots that go across the screen, because what's happened is that your application has been pushed to disk and it's being pulled back from disk. Okay, but usually the last 5 or 6 applications that you have in memory are going to switch back very quickly. And the ones that you saw there, you can see that if I want to switch back to my calendar, for instance, even though I just had that game in memory, it immediately brings my calendar up and I am productive immediately. So that's really an important scenario. It's something that you just really need to take care of when you're building applications. Make sure that you handle fast application switching, because your end users will love you. And I suspect if you don't support it, they will hate you. And that usually translates to ones in the ratings. So what's going on behind the scenes there? Let's talk about it. There's 2 scenarios that are related, and I've mentioned them already. There's fast application switching, and what that means is that your app is still in memory, but it's in a state called dormant, which means it's kind of sleeping. It's not doing anything. It's not taking any battery. It's not doing any processing. So it's still in memory. That means that we can turn it back on very quickly, but it's not doing anything. So let's see what that state is. So the first state, obviously, is your application is running, and that's a good thing. And then at some point, the end user hits the start key, right? And that means that your application has done something, and you get an event that says your application has been deactivated. And at this point, I had a clicker here. It's up to you to make sure that you save the state of your application so that you know when your application comes back, you can do what needs to be done to make sure that the end user gets back to the same state they were in. You have only a few seconds to do that, so don't try and do all sorts of fancy stuff and save your stuff to the internet and all that stuff. What you really want to do is save your state very quickly locally and get out of memory. And the get out of memory is not really optional. We're going to do it for you. And so you need to be ready. So you basically deactivate, and then at some point, your application becomes dormant. And what dormant means is that you're still in memory. All your threads and timers and all of that stuff have been turned off. All of your access to resources has been disconnected, and you're just waiting. You're just in memory, so you're sipping at the battery, right? You're not doing almost anything. You're certainly not processing, and so not affecting the speed of the process or the user experience in any way, but you're dormant. And then at some point, the end user will hit the back key to come back, or they'll go through that task switcher. And right, so we talked about that. And then at some point, you will get activated, and there's an actual event that you'll see that gets triggered, and you'll be able to do something there. And really what you want to do is make sure that you double check that your state is preserved, and if it is, then you're back in the running state. This is kind of the happy path. This is the one where the end user just switches back and forth, and it's great. As I said, it's only going to happen for probably the last 5 applications that you have in memory, sometimes even less, depending on how big those applications are and how much memory the device has. So there is another scenario, which is what happens when your application is dormant. So every application goes through this scenario where you go running, deactivated, you're dormant, and then at some point, if the end user has a big stack of applications, the operating system is going to say, sorry, there's not enough memory, or I'm going to take one of them and do what's called tombstoning. And so that's what happens at that point. Now, what happens with tombstoning is you're actually out of memory, and so it's going to take a little longer to come back, but it still works pretty much the same way in terms of how you handle it in your application. When the end user hits the back button to come back to it, at some point, you will still get the activated event. And then at this point, you will check your instant status, and you will see that the application preserved property is false. And so that means that you have to make sure that you reload a bunch of stuff and make sure that you have that in memory before you go into your running state. And at this point, the running state that's when you would see that resuming with the dots, right? Because it's just a little slower for the end user. Any questions on that? It's a fundamental topic. You really have to understand the application model. If you understand this, then tombstoning is actually fast application switching and tombstoning is actually a pretty easy thing to do in your application. This This image, don't try and copy it down, it's actually in the documentation, and it kind of walks through all of the various states that you go through when your application starts. You get a launching event, and then pages on navigated to, and so on. But the ones that are important in tombstoning is really the application deactivated event and the application activated event, right? And then you can also use the page on navigated from and the page on navigated to method to override those to make sure that you do things that are important in your application. So what does that mean? And there's a very simple method to doing this, right? If you look at the activated method, you basically have to make sure that you check whether your application is coming back from being dormant, which means you really don't have to do a whole lot, or you're coming back from tombstoning where you need to reload some stuff and make sure that stuff is reconnected and all of that stuff is good. So that activation handler is where you test for that flag. It's the E is application instance preserve flag. That's where you do most of the work. How am I doing? It's really quiet in here. Are you guys all thinking about Valentine's Day? Is that what it is? No? Okay. Did everyone send flowers to their loved ones? Amazon, right? Okay, great. How many people had an anxious call first thing this morning? They forgot. Yeah, okay. You get the prize. There's always someone. All right, so as I said, there's some things that you have to worry about when you're doing fast application switching or tombstoning, and you have to be careful of some of your resources. So the operating system will do some of the things for you, but there's some things that you have to take care of. And so if we go through the different steps, the deactivated application, right? When the end user hits the back button, you get that deactivated event. And you get the on navigated from on the page event method, and then you get a phone application deactivated event. At this point, there's some things that you have to worry about. And these are the resources that you're taking care of, depending on what you're doing on that page. So for instance, if you have a media player, you'll want to pause the media player, right? So that and take a note of where you were in that video or audio so that you know that you can, when the application comes back, you'll set yourself back to the same spot or maybe a few seconds back from that. So media player, media element, sound effect instance, you pause them, vibrate controller, all of your sensors, all of those things you have to figure out what's going on. Your photo camera, you're not going to be able to preserve that, so you dispose it. And then you save your state. This is the point where you would make sure that you track things like, where am I in my video or audio so that I can come back to the exact same spot. And then at this point, there's not much you can do because, whoops, going the wrong way, because the framework will then detach all your resources. So even if you don't dispose of your media elements, if you don't dispose of your photo cameras, you've lost them. So it's important that you do it, because if you don't do it, we're going to do it, right? And then at this point, all of these things happen. Things like networking gets canceled, sensors, notifications are suppressed, XNA audio just gets paused, your sockets are disconnected, your media elements are disconnected, your cameras are disposed. And so if you don't do it, we're going to do it for you. And then at that point, we do it, and then at that point, your timers and threads get suspended, and you're in dormant state, right? Any questions on that? So when you come back, you kind of go in reverse, right? So your dormant app, then the framework resumes your timers and threads, and so then you can start doing stuff. The framework will attach some resources, and then other resources don't. So for instance, sockets, nothing will happen. The system will not try and remember what socket you had open, so it's up to you to make sure that you go and do that sort of thing. So when you do that, you need to go and reconnect your sockets, new up a new photo camera or video camera, and then restore any app state if it was tombstoned. Any questions on that? It's kind of an important topic. How many people are doing this already? And so you're just coming just for fun? You're testing me, right? Okay. Uh-oh, some people know this stuff already. There's a number of ways that you can save your state. There's two ways. There's isolated storage and there's state storage. Isolated storage is basically when you're saving to disk. And there's no disk, but you're saving to an isolated storage that will be there when your application relaunches because it's persistent. State storage is the sort of the opposite of that. It's the equivalent of isolated storage, but it's in memory, so it's much faster. And so the ideal is if you use both, so that you can take advantage of keeping track of your data using isolated storage so that you're persistent between application launches, and you would use state storage to save stuff so that you can restore your state between dormant and tombstoned applications. And so at this point, let's actually have a look at a demo. And to do that, I'm going to jump into Visual Studio. Okay, so here I have an application. It's called the Captain's Log. And I have 3 different versions of the application, and it sort of progresses doing a bunch of different things. Let me just run it and show you. Whoops, I guess I should have set my zoom level. No. This is my red or magenta Nokia because of Valentine's Day, right? Any women in the audience that even appreciate this? No? Okay. I didn't think so. Oh, well, I did it for myself, I guess. So this is an application called the Captain's Log, and really all it does is it allows me to type something and it stores it. And we'll use that as sort of an example of something you do. So if I type something in here, and let me just type Happy V-Day. Whoops. Sorry about that. Let me store that. And now if I view my log, it's now recorded the date and the time and whatever text I put in into that, right? And so now if I hit my start button, does anybody remember what happens when I hit the start button? What state is my application in now? Anyone? Shout it out. Dormant, exactly. So my application is dormant because there's nothing else running, right? If I hold down my back button, you'll see, I'm pretty sure I don't have anything in memory except those 2, right? I have my start screen. And so if I come back to it and I view my log is all there because everything's hunky-dory. Now, if I actually hit the back button and exit my application and come back to it, this application doesn't actually store anything, and so my logs are gone. And so the next step would be, okay, well, let's actually persist some of that stuff. And so let me close this application and open the next one. This time we'll open it, and it actually stores it. Here we go. And we'll come back to this page in a minute. Let's actually have a look at what's going on here. And so if we come in here, I'm actually looking at my app.xaml file. And in the app.xaml.cs file, there's a few events that are being handled. And so when my application launches, it's going to load from isolated storage, and I'll show you what that means in a couple of seconds. And then when my application closes, it's going to save to isolated storage, right? And so at that point, good things are happening, right? Because I'm starting to save stuff. Now, I'm not doing anything in the activated and deactivated yet. We'll see that in the next step. But let's see what happens in this case. So let me run this. And so now if I write, let me just make sure there's nothing in the log. There shouldn't be. And so let me write, this is Captain's log number 2. If I store that, view the log, it's in there. If I hit the start button and come back, it should have the same behavior, obviously, because you don't really need to do anything at this point. If I exit and relaunch the application and view the log, it's now saved it to isolated storage, and so it's persisting between states. Now, if I do one thing, and I add log number 3 and store it, and maybe even I'll type log number 4, but not store it yet. It's actually in my edit control. And I hit, so let me actually show you one other thing. This is something I meant to show you. So if we look at the project properties, we can actually, if you go into the project properties in the debug tab, there is an option to force tombstoning, right? This makes it much easier for you to test both fast application switching and tombstoning, because you don't have to constantly run your application and then run 5 other applications so that your application gets tombstoned. Basically, by setting this checkbox, anytime I hit the start button, that application doesn't get fast application switched, it gets tombstoned immediately. And so I can test for that behavior. So we're going to do that, and now we're going to run the application again. And, okay, let me just exit. Sorry. Run it again, which is what I meant to do. Okay, so everything is here. I have my log. I have my log number 4. Now what we're going to do is hit the start button. And if I come back to it, it's still there. And why is that? Let me store that. Type log number 5 and tombstone and come back, and it's still there. I think I loaded the wrong application. Let's actually have a look at what's going on here. So if we look at the application closing, it's saving to isolated storage and then loading from isolated storage. And those are 2 helper events that are happening up here. And basically it's using, here we go, program data. So it's using 2 variables, the log text, which is the stuff that we stored, and then the log entry is the one in the first page. And then the save to isolated storage uses save text. There's another helper, the log and the entry to the log. And then isolated storage is doing that same thing from isolated storage, loading it. And so here are that state, and then here's the isolated storage where it's actually saving this. So save text isolated storage takes the information, puts it into the file name, and then news up a isolated storage settings file, and then removes it if it exists already, and then adds the file with the new text, and then saves it. And then same thing when you're loading, it's doing the same thing. It's loading it. Now, the other thing that we didn't do is, let me just load that project. Here it is, the complete log, is when we do, here it is. Now, if we come back in here, you'll notice that this time, we're actually handling the state objects as well. And so, let me come back. This is not, here we go. So on the application launching, we load from isolated storage. We had that before. But this time, when the application is activated, we're checking if the instance is preserved, and then we load from state object. And then same thing, if it's deactivated, you save to isolated storage and save to state object, because you don't know if you're going to come back or not, right? When you get put in the stack, you don't know if your application will ever come back. And so that's why you need to make sure that you save all that. And now if we run that, it should behave a little better. I'm not sure why. Let me actually uninstall it. Okay, and run this. So now there should be nothing because I just uninstalled it. And so now if I put log number 5, and store it, and then if I say log number 6, but not store it, if I hit the start button and come back, that should all be there because that was dormant. Now if I do the same thing by, well, it's still running. Let me just stop it. If I do the same thing when it's running, when it's tombstoned, so we have the log, have everything there. We store that. If I type log number 7, and if If I hit the start button, it should get Tombstone. And now when I come back, you saw that perceptible pause there? You didn't see the resuming because it didn't take long enough. After a few seconds, you would have seen the resuming screen. But that pause meant that you're coming back from disk. And then after coming back from disk, we were actually repopulating those edit controls and the log files. Any questions? How am I doing? Is this interesting? Is this new? Do you think you could do this? It's really quiet in here. Okay. So let's come back to my slides. A few things to note. The first thing is there is only ever one Windows Phone application that's in the foreground at any one time. So even though you have applications in the background, there's only one application that your end user has access to, and that's the one application that has full access to the processor, has full access to all resources and all of that good stuff. So even though you're putting stuff in the background, you don't actually have access to it. The end user doesn't have it. So the start button and the back button are used to start new applications and return to previous ones. That's kind of an obvious one. If an application is replaced by another one, it's either dormant, that means it's still in memory but not running, or tombstoned. And then applications must use the populate methods. And so this is the on activated or the on deactivated events to track all that. And so we're going to move on and talk about background tasks. So now would be a good time to ask your fast application switching questions. Anyone? Really? Okay. I have done such an awesome job that you all get this. So the next step is background tasks or multitasking, depending on how you want to talk about it. There's a few different types of multitasking capabilities in Windows Phone. This is something that we added in Mango in the latest release. I should stop calling it Mango. It's actually Windows Phone version 7.5. The primary ones, the ones that are the most generic, are what we refer to as background agents. And there's two different kinds. There's a periodic background agent. It's one that runs every 30 minutes. And then there's one that's called a resource-intensive agent. And that one is one that runs when you have power and you have Wi-Fi. And we'll talk about all that good stuff. There's the background transfer service, which is where you would take advantage of a service that we have in the operating system to transfer files. And so we use a hardened service, and so we give you access to it. So anytime you need to transfer files from the internet to the device, the easiest, fastest, and most efficient way to do it, to preserve battery life and to do it while the application is not in the foreground, is to use the background transfer service. And then there's also some alarms and reminders. These are easy ways for you to basically alert the end user that some event has happened or is about to happen. And it depends on the scenario within your application. But that's kind of a handy thing. It's kind of like we have in the operating system alarms. So for instance, this morning or last night, I set an alarm so that I woke up on time. You use the alarm. We use the alarm service. That's the exact same service that you would use to set an alarm within your application. I'll show you what that means in a couple of minutes. And then there's also reminders, which are the equivalent of in the Windows Phone calendar. When you have an event that's about to happen, you have a meeting maybe or a phone call that you have to do, you get a reminder for that. You have access to that same service so that you can set reminders within your own application. And then finally, I mentioned this earlier, there's also background audio. And this is where the same way we have our Zune service that runs audio in the background. So even though the end user is in Outlook doing email, they may want to listen to their music. We have a service that does that in the background. It's what we use for the Zune service. We have made that available for you if you have a music service. For instance, if you have a streaming radio station or maybe you have your own music service, this is something that you would have access to, and it actually integrates directly into the operating system so that you use the standard universal volume control and all that good stuff. How many people are doing audio applications today? Yeah, that's kind of what I thought. So not too many applications that do this, but the ones that need to do it, it's an important scenario. If you can't do background audio, it's kind of not really exciting to have audio running only in the foreground, right? So let's talk about the generic background agents. So there's two different kinds, the periodic and resource intensive. An application can have one of each, and I'll show you what each one of those does in a couple seconds. These are initialized in the foreground, so you can't start them unless the end user actually runs your foreground application. And as part of your foreground application initialization, you would then launch background tasks, and those background tasks are then persistent across reboots and all of that good stuff. And the user always has control. That means that if your application is doing bad stuff, the end user can always go to the control panel, the settings page, and turn off your background task. And if they do that, there's nothing you can do to turn it back on. So we always give the end user the control over their own experience. Agents run for 14 days, but they can be reinitialized. And so if I have a task, when I launch my task, I would set a background. If I have a app, the app in the foreground would launch a task. That task would run for 14 days unless the end user launches my application again and I reinitialize that. And the reason we do that is because we want to make sure that applications that launch background tasks, maybe the end user has launched and started an application that does a background task and then forgets about it, never runs that application anymore, doesn't care about that application anymore. So the theory is that if the end user doesn't run your application at least once every 2 weeks, they probably don't care about your background tasks. And so we're going to take them out of memory. And then when the end user restarts the application, then you can reinitialize your background tasks. Does that make sense? That kind of eliminates the possibility that you have a phone that has hundreds and hundreds of background tasks that are doing stuff that you no longer care about, right? The traditional, I guess it's called crapware on PCs, right? Where there's stuff going on that you don't care about, but it's been installed and you don't even know it's there. Any questions on this stuff? Yes. Finally, a question. I should have a prize for you.
The system may take into account which background task to remove. Is it last con that gets removed?
So the question is, how does the system know which background task to remove? And are you talking about now after 14 days?
No, the maximum of 18 tasks.
Yeah, so there is a maximum number of tasks, and if it hits 18, then the first one in is the last one, is the first one out, right? First in, first out. So there's no way for you to set your priority higher than others. Like I said, there's two different kinds of background tasks. The most generic is what's called the periodic agent. This one runs every 30 minutes, sort of, give or take. It depends on what's going on the device. And you don't really have a lot of control, but the operating system will control that. And sometimes it might be 25 minutes, sometimes it might be 35 minutes. It depends on what's going on. You have about 15 seconds to do whatever it is you need to do. Send stuff to the internet, go and retrieve an RSS file, whatever it is you need to do. You have about 15 seconds to do it. If you don't complete in 15 seconds, too bad. You will get turned off and the operating system will move on to the next one. And basically the operating system will go round robin to all of the background tasks and give them each 15 seconds every 30 minutes or so. And there are some constraints. So your background task can only use up to about 6 meg and can actually only use up to 10% of the CPU. And as you can imagine, it's running in the background, and if it runs more than 10% of the CPU, then it starts to affect, pardon me, it starts to affect the user experience in the foreground, and we don't want that. There is a second kind of periodic agent. Yes? Is what? So the question was, is the constraints, the 6 meg of memory and the 10% of the CPU, enforced by the operating system? And the answer is yes. So if you try and use more than that amount of CPU, you will get shut down. And if you do it for too long, you will get turned off completely. If you try to do it over and over again. We'll try and manage the health. There's two things that we try to do. We always try and manage, we optimize for user experience and the health of the device, right? So if you're using too much memory, if you're using too much CPU, you will get turned off. Yes?
Is there a way that we can test it to see how much CPU task is taking?
So the question is there a way that we can test how much CPU is being used? There is a profiler in the latest release of Visual. I believe it does provide the ability to test for memory and CPU utilization. Oh yeah, pretty sure. Any other questions? Yes?
When I want to program an alarm clock, for example, and only every 30 minutes the agent runs, how can I get an exact time?
Okay, so the question was, well, what if I'm programming an alarm clock and I need to run it every 15 minutes or every 10 minutes, 5 minutes? That scenario where you would want to run outside of 30 minutes is not supported. So you have every 30 minutes. Now, the case where you mentioned, which would be an alarm clock, would be a different scenario, and it's one that we support using alarms and reminders, and I'll talk about that in a few minutes. But that's fully supported, and we have a different set of APIs that support that. But the reality is, if you need something that runs every 5 minutes or every 10 minutes, you need to rethink your scenario. The way you might be able to do it, and I caution you to do this, is to use push notifications. So you might be able to do processing on a server, and then if something happens, then push it to the device. But you have to be careful, right? Because if it's happening every 5 minutes, if you're sending a push notification to the device every 5 minutes, the system will support it, it will allow it, but if you have too many push notifications, you're turning the radio on and then off again, and that is probably, aside from the screen, I think the radio is probably one of the most intensive users of the battery. And so if you have like 500 or 600 notifications coming to your device, basically you can watch your battery meter drain very quickly. So don't recommend it. But if you do have stuff that has to happen outside of that 30 minutes, push notifications is something that you could do. If you could check for something on the server side, and then when it happens, then you push to the device. Any other questions? Yes?
Can we do asynchronous tasks inside the background?
Give me an example.
Accessing a service or that takes some amount of time?
So the question was, can we do things like accessing a web service or downloading a file? Well, file would not be a good example, but accessing a web service to retrieve, I don't know, RSS feed or some JSON, sure, absolutely. Again, within limits, right? Because you're limited to about 15 seconds. So you got to make sure that you've done everything you need to do within that 15 seconds.
When I start a background, so I just started and it's running, and then the 15 seconds are over. So the background is running for 1 hour, but the starting has been immediately. Does that count for these 15 seconds?
So I'm not sure I understand the question, but let me explain to you the way it works. So you, from your foreground task, would fire off a background task. Basically, you're telling the operating system, I have something that needs to happen every 30 minutes, and here's my code. And it's a DLL, and I'll show you in a few minutes, it's actually part of your solution. So you would have a foreground application and then a background task. And then from your foreground, you would tell the operating system, here's my background task. And then the operating system, every 30 minutes, will launch your background task and give it about 15 seconds. And if you don't complete in 15 seconds, the operating system will shut you down. Make sense? Does that answer your question? Okay. Any other questions? These are great questions, by the way. Okay, let's, was there something? No? Okay. Let's keep going. Oh, right, so we're talking about resource intensive. So periodic agents, like I said, every 30 minutes, it's going to happen. No matter what, middle of the night, middle of the day, it's every 30 minutes your application can happen. Resource intensive happens under a very specific criteria. It's when your application is on external power. That means you're not running on battery, but you've now plugged into either the wall or to the USB on your PC, and you're on a non-cellular network. That means, again, you're using the network from the PC because you're tethered to the PC, or you're using Wi-Fi. And the scenario here is you get home at the end of the day, you're at home, so you're using your Wi-Fi, you're not using the cellular network, and you plug your phone in because you're done for the day, and you're just going to put your phone aside. And then at that point, you have 10 minutes to party on, do anything you need to do. This is your typical application where you want to download tons of data at the end of the day, make sure that stuff gets synchronized, and you have 10 minutes, like I said, to do pretty much anything you need to do. And so that's kind of a handy thing. Same constraints though, 6 megabytes of memory, but you don't have the constraints of the CPU unless the end user is in the foreground. So if the end user is trying to do something in the foreground, it will try and control that. But for the most part, you have that memory constraint to contend with. Any questions on these? Sorry? Yes. Oh, so the question was, is that automatic? It is automatic. Your application can have one of each, right? So your application, when you build your application, you have one foreground app, just like you do today in Windows Phone 7.0. You can also have a periodic agent, and you can have a resource-intensive agent, and there are templates for that in Visual Studio to create those, and they will give you everything you need in your headers and all that good stuff. And then if you have a resource-intensive agent, it will automatically get triggered once those criteria are met. Yes?
Is that 10 minutes per agent or 10 minutes or
The question, yes. So the question is that 10 minutes for each resource-intensive agent, or is that 10 minutes for all the resource-intensive agents on my app, on my device? And it's per agent. So you can do a lot of data. You can do a lot of damage in 10 minutes.
So that means if I have 10 of them, I will have 100 minutes that...
Yeah, I believe so. I believe they are sequential, yes. I'm not sure about that, actually. Actually, if you want to email me, I will find out. That's a good question. I should know that. benriga@microsoft.com, or if you want to save the puppy, do it on Twitter. Let's see. So someone asked about what can I do and what can I not do in those background tasks. And as you can imagine, you can do pretty much everything except some stuff. So things like updating live tiles, pushing toasts to the screen, right? Those, you know how when you get a text message, for instance, you get that toast across the top of the screen. You can pop those on the screen. So that would be one way of your background task, notifying the end user that something's going on. That's probably the only way between tiles and toast for your background task to interact with the end user, to let the end user stuff's been going on. You can access location. You can go and retrieve the location. The location is actually cached, though. So if you have 18 background tasks and they're all accessing the location, only the first one is going to actually get the most accurate location. So if the end user is walking, it's going to access the location on the first one, it's going to cache it, and all of those background tasks will get the same location. Should keep that in mind. Accessing the network, reading and writing to the isolated storage, opening sockets, and pretty much any framework API except for some things. You can't do anything that's display-oriented. So any Silverlight pages and all that stuff, just don't even think about it. You can't do it. Most of the XNA libraries you cannot have access to. You cannot do microphone or camera for privacy reasons. We don't want applications in the background that are recording sounds or what's going on in the background. As you can imagine, that would be it could be a good thing, I guess. I don't know. And same thing, you don't want pictures of where you've been and all that stuff. So the sensors, you do not have access to any of the sensors. and you can't play audio. If you need to play audio in the background, there's a special scenario for that. It's the background audio task, and we'll talk about that in a few minutes later on. Any questions or concerns about this stuff? Okay. So let's actually have a look at how that works in the background. And so I am going to load. And this one's a little harder because so I'm going to run this task, and I'll show you what it's doing in a couple of minutes. It's basically doing the same thing. Let me actually do one thing. Whoops, sorry. I'm going to set my location. Oh, I don't have internet? Okay, so it's not going to be able to access my location. So location will come back as unknown, but let's just run it anyway, and that will give us a better idea here. Just stop that. Before I do that, let me just show you, I think I mentioned this earlier. If you look at this project, there's actually this solution has two projects. There's Captain's Log, which is the actual application, the one that we saw earlier, and then there's this location task agent. Let me run it, and then we'll come back and look at what it's doing. And so now, let me just store that. And then I'm going to start tracking, and I'm going to exit. And so this application is now running in the background. A couple of things. Well, we'll come back to talk about debugging in a couple of minutes. But I could now go and do stuff, right? I could go and run IE and do all sorts of, well, I don't have internet, but so I can't run IE. But at some point, and again, it's kind of hard to do this in a demo because I got to do some dancing because it sometimes takes a little bit longer than you would expect. So periodic tasks run every 30 minutes. So if you guys could just do what you need to do for 30 minutes and then just come back. That's not actually the case. So as you can imagine, it would be a real pain if in debugging, if you had to wait 30 minutes to test every run of your background agent. And so there's a way to change that so that it runs much sooner. In my case, I've set it to 60 seconds. But that's give or take, right? Because the operating system kind of controls that. Yes?
When do these 30 minutes start? When I start the program? Or is it internal timer?
So the question is, when do these 30 minutes start? And it's the operating system that controls that. So you have no control over that. So you just, all you know is that you will have 30 minutes between runs. So you have no control. You can't say start it on the hour or every 15 minutes, or you don't have control over that. Any other questions? So this thing is not running. This is always a pain if I come back to it. Oh, one of the things I did want to show you is if I come into settings in applications, you'll see that there is a control panel for Captain's Log. And if I click on that, I can actually turn off Captain's Log. And the end user can do this on your application. If the end user does that, there's nothing that you can do in your application to turn that background task back on. The end user always has full control. This would be where you would also see it if it had timed out. So if after 14 days it had timed out, it would be off. In that case, you could turn it back on again. But if the end user turns it off, the end user is the king, and they get to control that, and there's nothing you can do to turn it on. The one thing you can do is you can detect that the end user has turned it off, and you can pop up a window that says, background tasks are turned off. If you want background tasks, you will have to go to the control panel and turn them back on. Does that make sense? Anyone? Yes? I'm not following your question. If I click that to off, if I turn that off, the background task will not run. They say it won't be in memory. We'll take it out. It will be thrown out of memory.
You can't start a new one.
You cannot start a new one.
So you're turning off the ability to have background tasks.
The end user is telling your application that you have lost the ability to do background tasks.
Okay, so, and the end user cannot just kill one background task.
The end user doesn't.
Kill background task, you just say you can't have any.
Correct. Oh, I see what you're saying. Yeah, there is no task scheduler. There's no task list that says this background task is running right now. It would be hard for the end user to see it because they only run for, they're kind of transient. They come in for 15 seconds and then they're gone. And so the only control the end user has is this background task, I want to turn it off.
So is there a flag in the application to detect it's turned off?
So the question was, is there a way for the application to detect that background tasks are turned off? And the way you would do that is when your application launches, the first thing you should always do if you have background tasks when your application launches is you should go and reinitialize your background tasks. Remember, there are 14 days. And so every time your application launches, even if you've launched once today already, you should give yourself that extra hour or whatever, right? So every 14 days, they will get turned off if you don't reinitialize. So your application must do that every time it launches. That's a best practice. It's the right thing to do. You launch your application, you try and reinitialize your background task. When you do that, you will get an error back from the operating system saying, sorry, you can't do that, and here's why. And then you would see that. And at that point, you would then pop up a page that tells the end user, you're not going to get whatever your application does in the background. You're not going to get updated RSS feeds because you have turned off background tasks. If you want to turn them back on, please go to Settings, Applications, Background Tasks, and turn them back on again. Any other questions? Is this interesting? So clearly my background task is not working because it should have run a long, long time ago. And I don't know why. Yeah, it's not working. Let me just stop it. And let's actually have a look at the code. So in the main page, here is where my background task is getting scheduled, right? So I'm setting up my background task is called location task agent, right? And so my periodic task is being set. And if periodic task is null, that means it's not running. And so I want you to start tracking. And if it is running, then you want you to stop tracking. Basically, it's flipping the text on that. And so that's how you check if your background task is running. And then actually turning it on should be probably... Oh. That's where it is. So there you start tracking, and and here's where the background task is getting run. And so let me just give myself some more room so that I can show you what's going on. And so here you can see that I'm checking whether my periodic task is running. If it's not equal to null and periodic task is not enabled, then here is where, like I said, there's that message that you can tell the end user background tasks have been disabled by the end user. I think someone was asking about that earlier. And if not, There it is. I'm newing up a new periodic task. I'm giving it a description, and now I'm telling the schedule action service to go ahead and add the periodic task. And then remember what I said earlier, that it would be a pain if you had to wait 30 minutes every time your periodic task had to run. And so this is where you tell it, schedule action service launch for task, time span 60 seconds. Now notice I put that in an if block there that will only happen if I'm in the debug agent. If I'm not in the debug agent, then it won't. I mean, it just, there's no way that you could do that in production. If you try and submit an application that does that to production, then your application will fail the certification for Marketplace, and you'll have to take that out. So please don't try and sneak that in. We do check for that. And so I'm not sure why it's not running. Let me do this. Oh, still running. Let me turn off debug. And set it to 5 seconds. And rebuild. Run. So there's my A task. If I start tracking, and let's just leave it there, that start tracking is running in the background, and we should see in a couple of seconds. Okay, so clearly that's not going to, for some reason, it's not working for me. You know, I bet you as soon as I go back to my slides, it's going to run in the background. So we'll hear it, I guess, in a few minutes. So let's talk a little bit about debugging. I just showed you this a couple of seconds ago. Like I said, we really don't want to force people to wait 30 minutes to do your testing or debugging. And so you can set it so that it runs depending on how much time you need. Like you saw me do a few seconds ago, I can set it to 5 seconds. I can set it to 60 seconds. Something that makes sense for your application. It's conditionally compiled, and has to be removed in a production build. So when you go to a release build, you do not want to send that to production. The other thing is debugging that agent code. As you can imagine, when I exit my application in Windows Visual Studio, normally the debugger is detached. You may have noticed that that did not happen in this case. So when I run my application, it remains attached, and then you can set breakpoints if you want to. Let me close these off. And so my application is running. If I exit, you notice here that my application is still running, right? So my debugger is still enabled. And so I could actually set, so if I come into my scheduler, this is the actual code for my agent. And so here is, it's not really doing a whole lot. It's loading, initializing, and so on. And so here is where I would maybe set a breakpoint. If I set that breakpoint, and again, I apologize, I'm not sure why it's not working right now, but normally when it breaks, when it runs, you would hit that breakpoint, and then you would be able to debug it like any other application, including getting access to the stack and the stack and so on. Yes?
You have to close the application before the launch for test works.
You have to close.
You start your application, Captain's Log.
Yep.
You say, I don't know what text there is. Just start Captain's Log.
I did that earlier. Yeah. So you want me to launch it again? Okay.
Do stop tracking.
Yep.
Start tracking.
Yep.
And no pause. Close your app.
Close my app. So I've now exited the app.
It will launch 5 seconds.
Really? Okay.
Normally on MSDN, the reason is you have
Okay, so you're saying it has to, I've not seen that. I'll have to go and look that up. I've never heard of that. Normally, I ran this earlier today and it was working, so I'm not sure why, but launch, you're saying that launch for task will only run if the application is out.
Maybe it's reason 5 seconds is too short.
Well, I don't want to spend any more time on it. We've already spent some time on it. We can look at it later. And I'll make this code available if anyone wants to look at the code. More than happy to share that. Just email me or save the puppy and do it on Twitter. So I'm not aware of that, but I'll definitely look into that. I've never heard of that. So anyway. And again, same thing, the same way we could debug for periodic agents, it works for resource-intensive agents as well. And, well, we just did that. Okay, so I just showed you that. So let's talk about file transfer tasks. How am I doing on time? What time does this session end? Is it 2:15? So I have 10 minutes? Okay, I think we're good. So the question is around Windows 8 or Windows Phone 8? Is that?
Probably both.
Yeah, we're not talking about Windows Phone 8, so I can't answer that one.
We have the same issues on tablets about battery conservation.
I see. Okay, I don't know the answer to that. So the question was, let me repeat the question for those of you at the back. How do we handle this in Windows 8? And do you use the same mechanism, I guess? Is that what you're asking? And I'm sorry, I don't know the answer to that. I focus exclusively on Windows Phone, and I'm a little embarrassed to say I have no idea. If you do want to email me or send me a tweet, I can check with one of the Windows guys and figure that out.
Well, I was actually more interested in the follow-up question about and what about Windows Phone?
What about Windows Phone 8? I don't know what that is. I never heard of that. I don't know anything about that. That doesn't exist. Yeah, so we're not talking about anything beyond Mango right now. So all I can say is for anything vNext, stay tuned. Okay? Any other questions aside from anything related to Windows Phone 8 or any other code names that you may have heard that I won't talk about? Any other questions? Okay, so let's talk about, what are we talking about? File transfer. So file transfer basically is a service that we use internally to download stuff. So for instance, you may have seen, and I don't know this for sure, but I know that, for instance, when you download from Marketplace, it does that in the background, right? So when you have an update, it throws it into your start list, and then you can see it updating in the background. So that's a hardened service that we have done. So it's a service that we control. We limit the number of background tasks that are running, background transfer tasks that are running at any one time. Again, to preserve the user experience. You don't want like 20 background transfers happening at once, and you don't want them to be taking up too much battery and so on. And so what we have done is we've enabled this service that you can take advantage of that to download files to your application into your isolated storage. And it's pretty simple. You basically say, here's this file. It's out in the cloud somewhere, either on my server or on Amazon or Azure, wherever it is. Here's where I want you to put it in isolated storage. Go and do it. And it adds it to a queue, and it goes and does it. And then whether your application is running in the foreground, or even if your end user exits your application, that transfer will happen. And you, as part of your application, you can check the status on those background tasks because you know what they're called, right? You've given your background transfer task the name of something. So for instance, I would call it, the benriga.jpg download. And then I can go and say, well, how far along are you? How many bytes have you downloaded? Are you completed? Did you error out? And you can check all of that stuff. And I'll show you how that works in a couple of seconds. There are some policies. Again, there are some restrictions and policies that you do have to control. Maximum file upload size is about 5 megabytes. You cannot go over that. If you try and go over that, will just tell you sorry, and it will stop. And the maximum download file size over cellular networks is 20 megabytes. So if you try to download a file over 20 megabytes on cell networks, it will just put it in the queue, and it will say, sorry, I'm not going to do it. And then when you get onto Wi-Fi, those transfers will happen. Make sense? And then over Wi-Fi, it's 100 megabytes. And so if you need bigger than 100 megabytes, then it's up to you to chunk it up on the server so that you can... Basically, what we're trying to do is make sure that no application monopolizes that transfer service, right? Because all of the applications running on the device are sharing that service and are sharing a queue. So your application, if you queue something up and some other application queues something up and another application queues something up, there's only one transfer that's happening at any one time, and the operating system is controlling that. And so if you had a 1 gigabyte transfer, then you would be monopolizing that transfer service. All the other applications would have to wait for 3 hours or whatever it was to download that. And there's ways for you to manage it. You can track how many file transfers you have active, and you can perform transfer management as required. There's lots of good information on that. I'm not going to go into a lot of detail, but pretty much anything you want to do, you can do. And let me just show you a quick demo of that. I'm just going to show you, let me just load it. Oh, it's still running. Let me just stop this. And this is a pretty trivial application. It's going to download a file from a server that I have out on the cloud. Let me just run it, and then we'll show you the code behind that. And so there's the name of the file. I'm going to start fetch. And that start fetch has now actually sent something to the transfer service, and the transfer service is now retrieving that file. Oh, no, it's not, because I don't have internet, right? Someone should have reminded me that. Do we have... Here, let me see if I can quickly grab internet. Any questions while we're waiting for that Ethernet cable to connect? Yes?
Background file transfer needs 3G or Wi-Fi connection. It's not working over normal cellular network. Why is this? What's the reason for this?
So the question was, background transfer file service doesn't run over 3G? It does run over 3G.
Under 3G. So I have normal GPRS connection on my mobile phone.
Yep.
So background file transfer won't start. What's the reason for this?
Actually, I was not aware of that. So you're saying that if you're running on Edge or GPRS, it won't start your background transfer? I did not see that. I did not know that. So I suspect that that's probably something that we have worked out with the cellular carriers, where they don't want a lot of data being transferred over. I can imagine trying to download a 20 megabyte file over Edge or GPRS would be a painful thing. It's a pity. Yeah, I agree. Get 3G or LTE. Any other questions? All right. Did I get my internet yet? I did. Okay. So, whoops, let me just run that again. I uninstalled the wrong one, didn't I? It's going to happen in the background, so just so I can show you. Okay, let's try this again. So now it should initialize, and you'll see it's like 1.5 megabyte image, and they're downloaded. And so not that exciting as a demo, but what that showed you is when I clicked that start fetch, I wasn't doing anything other than I've set up an event where the transfer service is now telling me anytime anything changes, please let me know. And then I was updating the screen with, and you saw the number of bytes that were being transferred, and then you can see at the end where I'm showing completed. So if we go and look at what's involved there, so that's the display image. So here's where I set up my transfer service. This is the button that gets clicked when I did the start transfer. I'm giving it the name is coming right off the screen. It's just pulling it out of the XAML. I'm creating a new transfer URI, and then I'm creating a new request using that URI, telling it it's a GET, and then here's the download file, right? File name. And I'm telling it where to put it, and I'm setting any options, and then I'm using the try block to add that transfer request, and then it's coming back whether I can or cannot, catching those exceptions. And then I'm binding event handlers to the progress and status changed. So anytime anything changes in the progress, well, I'll show you those in a second, but I'll use that to display. In this case, I used it to display the number of bytes that had been transferred, and then status changed would be if it errored out or if it completed and so on. And so let's do the progress changed first. And progress change is pretty straightforward. It's changing that status test block on the screen with number of bytes received. It's basically pulling out the number of bytes that have already been received and just showing the end user that something's going on. And then the transfer status changed is checking the status, and based on whatever the status is, it's updating whether it's completed or if it's an error and what the error might be. And then once it's done, you want to remove that transfer request. You do want to remove your transfer requests because they will stick around and fill up your queue, and it won't automatically clean that up for you. So you want to make sure that you clean that up. Any questions on that? It's pretty straightforward. It's kind of, you basically set where it's coming from in the cloud, where you want it locally. Go ahead and start it, and then you can monitor it with a progress changed or a status changed. Yes?
That's not the background task. The application has to run.
So the question was, well, that's not really a background task because the application was running. It was running in our case, but it did not have to be running. So if I actually start that task and exit the application, that background transfer will still happen. I left the application running just to show the progress. Now, obviously, you can't show progress if you're not in the foreground, right? You can't check status if you're not in the foreground. But it is convenient if you need to download 10 new files. Maybe you have to download an RSS feed or something. You could download that, set your background transfer service to download that, and then maybe you have a periodic task that checks whether the status is completed. And if it's completed, you may want to process it.
But because I cannot do anything when the download is complete, I cannot do like processing with files.
Okay. Oh, okay. Yes. So the question was, well, I want to be able to set a trigger or set an event when the file is completed so that I do something with that file. And you're right, the background file transfer service doesn't support that. But if you combine the background transfer service with the periodic agent, you could check that, right? So you would start your transfer service, and you could actually use the periodic agent to download, to start a background transfer service, and then periodically check, has it completed, right? Because you don't know how many other files are in the queue ahead of you. It could take 20 minutes, it could take an hour, it could take 20 hours, it depends, right? And so you would check every 30 minutes, has it completed? Oh, it's completed. Now I can transfer. Now I can process it. Does that make sense? You're welcome. Any other questions? I think I'm almost out of time. Or am I out of time? I'm out of time. 1 minute? Oh, wow, okay. You guys asked too many questions. You saved them all for the end, didn't you? Okay, so let's talk about scheduled notifications very quickly. These are alarms and reminders. Someone asked about the alarm clock scenario earlier, and essentially they are what you would expect them to be. An alarm is exactly that. I want the end user to be advised that something has happened, and you advise it. And those are modal. The end user can't do anything on the screen until they actually accept it or dismiss it or what have you. They don't get stacked up. And there's no application invocation and there's no stacking. The reminders are a little bit different in that you can, just like a calendar, you can have a stack of them and you can swipe left and right and look at which ones are there. And if I want to do something with that, if I tap on the text, it will actually launch the app and tell the app, oh, the end user has actually tapped on this. And you can use deep linking to do something with that. So for instance, when your app launches, you can check whether the end user's tapped on a reminder and then take them directly to that reminder or whatever that event is. Does that make sense? Creating a reminder is pretty straightforward. I would even say trivial. An alarm is just the same way. You new up a reminder, you give it a begin time, you give it the content, tell it whether it's recurring over and over again, and then you give it a URI so that when the end user taps on it, something happens, and you add the reminder. You have to remember that once your reminder has happened, you also want to remove the reminder. Again, you want to keep your queues and all that stuff handy. And then the operating system handles everything else. It just puts it into the queue, and it becomes a reminder just like the Outlook, sorry, not the Outlook, but the calendar has reminders. Your reminders would get added to that same queue of reminders that happen to remind the end user that something needs to happen. And like I said, you need to make sure that you remove reminders as part of that. Otherwise, they will just kind of pollute your system there. I think I'm out of time, so I'm not going to do this demo. If you do want to see the demo, drop me a note. And like I said earlier, I'm more than happy to answer any questions via email or what have you. Background audio, we're out of time, so I'm not going to talk about it. They did ask me to make sure that you understand that there are some resources that you have available to you. These are available from the local team, and so things like ak.ms.mobile phone start, that will get you basically I think it takes you to the Belgian site where it gives you everything you need to get started. And then get to Mango series. There's all sorts of resources there that you have access to. I am going to stop there. Like I said earlier, save the puppy, follow me on Twitter. And unfortunately, I think we've run out of time. So if you do have questions, I'll take some here. I think the next speaker wants to set up. And if we can't finish, then we'll take it outside, and I'm more than happy. I'm here all day, and I'm here tomorrow also. So if you want to schedule time, drop me a note. More than happy to do that. Thank you very much for coming.